Welcome to Luca and Miguel. Enjoy the video.
You start by collecting the right input. Record in a quiet space with a cardioid mic and target -6 to -3 dB peaks so the model has headroom. Once done, export a 24-bit WAV or high-quality MP3 at 44. 148K HC because AI models perform better with consistent sampling. Make sure to name files and add simple metadata like language and speaker to speed later steps. This prevents confusion and ensures reproducible results when you train or fine-tune an audio AI. You now preprocess and set up the model, run denoising and remove clicks, then normalize to a consistent RMS so the network learns meaningful patterns. Next, choose the right architecture, speech-to-text, voice clone, or enhancement based on your goal, since each optimizes different losses and features. Once chosen, split your files into 80% training, 10% validation, and 10% test to monitor overfitting. During training, adjust learning rate and batch size while watching validation loss to ensure steady improvement without unstable jumps. You finalize by evaluating and deploying. Compute WER or MOS for speech models and SNR or spectral distance for enhancement to quantify quality, because numbers reveal blind spots. Then deploy as an API or container and monitor latency and resource use to meet real-time needs. If you spot artifacts or weird timbre, retrace steps, tweak preprocessing, augment training data, or fine-tune the model with targeted examples. This targeted troubleshooting usually resolves most quality issues without redoing.
Thanks for watching and please subscribe. It's the best investment you'll ever make.